Hello, I am Mallikarjuna Rao Mudigonda, Technical Marketing Engineer in Data Center Group. In this video, I am going to talk about auto priority connections and how do we create them using Nexus Data Broker. So, first of all, let's try to understand when should we use auto priority connections. So this is the criteria. The thumb rule when to use auto priority connections is when two connections have similar sources, like in other words, the common sources, like the connection is actually ingested from one source and it has two different overlapping filters. And the third criteria is the tools for the connections is different, right? So this is when we have to pick up auto priority connections over regular connections. If you don't create an auto priority connection, this can be achieved by creating two connections by assigning different priorities as well, right? But the intent of the auto priority connections is to remove the hassle of assigning the priorities manually. So NDB controller will take a decision for you to assign the ACL priorities automatically without the user intent to have any priorities on the connection. I'm going to take a couple of use cases to explain the auto priority connections and walk you through how we can create them using NDB UI. Here is a first use case. As you see in the topology, I have an NDB switch. There are two ports which are ingesting traffic, like port 1 and port 2, which is actually coming via span. And I have three tools which are Wireshark and IDS and Sniffer. They are connected to three different ports, Ethernet 1/11, Ethernet 1/12, Ethernet 1/6, respectively. The use case what I'm trying to achieve here is I got three tools. My first tool, which is Wireshark, which is called M1 tool. M1 tool just need TCP/80 traffic and 443 traffic. The sources for that connection is port 1 and port 2, which is Ethernet 1/1 and 1/5. Similarly, for the second tool, IDS and IPS tool, it also need 80 and 443. Similarly, the sources are 1 and 2 again. And the third tool, which is a sniffer, which is the interested traffic for this tool is just 443. And the sources for the traffic is Ethernet 1/1 and 5. As you can see, the common thing about the three use cases or the three requirements is we have a common source, we have a overlapping filters, and the tools are different. When I say overlapping, port 80 and 443 are overlapping and between monitor 1 and monitor 2, and 443 is actually overlap for all the three tools, M1, M2, and M6. Let's take a look at how we can create this in auto priority connection. So we are going to go to the connection module and then click on create auto priority connections. So when you choose auto priority connections, there is no input for priority. There is the priority column itself is actually not highlighted. So I achieved this by creating two connections, which are C1 and C2. The subscript, the superscript, what you see is clearly written as auto priority, which means C1 and C2 are auto priority connections. So for C1, I have tool M1 and M2. And as you can see under M1, there are two filters, right? HTTP, which is port 80 and 443. And another M2, for the same connection, it is 80 and 443. And the priority is automatically selected. We don't need to create anything. So the intent what I showed in the previous slide is actually created by two auto priority connection. The second auto priority connection is C2. And again, for the C2, the sources are again common, like Ethernet 1/5. And we created this using M1, M2, and M6. Whatever the M1 need just 443, M2 need just 80 and 443, and M6 need only 443, right? So this is how we created the auto priority connections. Let's take a look at it, how the ACLs are created for the auto priority connections. Remember, the sources are Ethernet 1/1 and 1/5, and the tools are connected to 11, 12, and 6. As you can see the ACLs, we automatically know what ACL to write for redirecting the traffic to the tools. You can see, observe the ACLs on Ethernet 1/5, 1/1, and 1/5. That's where the sources are. 1/1 and 1/5 are the sources, and it is redirected to the tools. Let us take one more use case. As we discussed initially, the auto priority connections can also be achieved by creating two different connections with manually entered priority. Let's take a look at it. Here the use case is I have a NDB switch. The copy traffic is coming on Ethernet 1/1. I have a tool by name tool-235-1, and I have another tool-235-2, which is connected to 41 and 49 respectively. The use case or the intent of these connections are, I have a tool 1, which is tool-235-1. It needs all the IP traffic and the sources are Ethernet 1/1. And I have a second tool, which is tool-235-2. It needs only port 80. And again, the source is Ethernet 1/1. As we initially discussed, the sources are common, which is Ethernet 1/1. The filters are overlapping. Here, the first tool needs all the IP traffic. When I say all IP traffic, it is inclusive of port 80 as well. And the second tool just needs port 80 traffic, and the tools are different. So this is the perfect use case for creating auto priority connections. So how can we create this intent of the connections with a regular thing? As you pay attention, the first connection is actually having a priority 100 and the second connection is having priority 200. It needs a little bit of thought process to understand the priorities so that the tools get the right traffic, or else one of the tools might be losing out the traffic. So the way how I created this is two connections. Remember, I did not use an auto priority connection here. These are two regular connections. The name of the connection is C1 match IP and the second connection is C1 match TCP, and I have the priority 100 for the first connection and the priority 200 for the second connection. And as you can see, the ACLs on the source port, which is Ethernet 1/1, are as follows. If I were to create the same intent with the auto priority connection, all I need is just one auto priority connection, right? And the name of the connection is C1_AP, and the superscript indicates clearly it is an auto priority connection, and the source of the auto priority connection is Ethernet 1/1, and there are no two connections. Automatically the controller choose a priority for you, and the tool 1 need just the whole match IP, and the tool 2 need just only TCP/80. This is how we created, and as you observe, the ACLs for Ethernet 1/1, which is the source port, are as follows. Thank you.